Hello, everyone, and welcome to the second session on circles. So, today we are going to start with a question, which would be the revision for questions that are the theorems that we learned for the first session, and then we'll move on to more theorems on circles after we solve this question. So, as always, give this question a try, and then we are going to come up with the solution. Okay, so I hope you guys have given the question a try. So let's read the question together and see what they have asked. Okay, so it says that two chords AB and AC of a circle are equal. Prove that the center of the circle lies on the bisector of BAC. So whenever you get a question, first of all you'll draw the circle, right? So let's draw the circle, and it said that two chords AB and AC. So from point A, we will draw two chords. So if this is point A, so we are drawing two chords of equal length. So one is AB, the other one is AC, right? And the center of the circle, let's mark it as O. So says that prove that the center of the circle lies on the bisector of BAC. So BAC, so let's draw the bisector here. So basically what we have to prove is angle BAO is equals to angle OAC. So from what is written in the words, we convert it into what we have to do in terms of equation, right? So the bisector of BAC at the center of the circle uh, is lying on the bisector of BAC. Basically, that's what we have to prove, and that's what we wrote in words. So let's see how we can prove that. Okay. So what it is given is let's join OB and OC. Okay, and the reason why we are joining it is we have the triangle, and we'll try to see what we can do with the triangles. Okay, so let me draw it with a different color. So let's join these two, and let's see what relationship we can have of the triangles. So let's say in triangle BOA and triangle AOC. So what we have is AB and AC are common. So AB equals AC. So this side and this side is equal. OA is common, and OB equals OC, right? Why? That is the radius. And AB equals to AC, why? That is given. So we get side, side, side. So these two triangles are basically congruent triangles, right? So all sides and all angles are equal. So if they are congruent triangles, then let me write it down. So therefore, triangle BOA is equal to triangle AOC, right? They are congruent triangle. So if they are congruent triangle, the angle BAO is equals to the angle OAC, because all angles and all sides are equal. So this angle is equals to this angle equals to this angle, and this angle is equal to this angle, right? So all angles are equal. So that's why, and all sides are also equal because it's a congruent triangle. So very simple question, and so that's the proof for this question. So now let's move on to the other theorems that we have for the circles. So let's go on to it. Okay, so let's write down the first theorem. So theorem one. So what does it say? It says that the angle subtended by an arc of a circle. Let me first explain it and then I'll write it down. So let's have a circle. So the angle subtended by an arc of a circle. So let's say this is an arc. Let us call it as AB. So the angle subtended by an arc on the of a circle at the center. So let's say this is the center. So this is the angle subtended at the center. Let's call it X. Okay. And is double the angle subtended by it at any point on the remaining part of the circle. So remaining part of the circle If we subtend angle, there can be infinite number of angles that it can subtend, right? So they are saying that if this angle is y, then x is equals to 2 times of y. Basically, that's what they are saying, right? So let me write it down in words. So the angle subtended by an arc, subtended by an arc of a circle at its center, right? So subtended by an arc, which is basically AB, at its center, which is basically the angle x, is double the angle subtended by it, meaning the arc, at any point on the remaining part of the circle. At any point on the remaining part of the circle. Okay, clear? So the angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. So at remaining part of the circle, if the angle is y, then the angle at the center is 2 times of y. So that is basically theorem 1. So let's move on to theorem 2. And basically we are going to do a few practice questions, but these theorems are actually revolving on very similar concepts. So let's cover all the theorems and then we'll do a few problems on those. So theorem 2 says um, angles in the same segment of a circle are equal. So basically a continuation to the previous theorem. So basically let's use the same picture to depict that and write the theorem here itself. So basically it says that the angle in the same segment. So if you are drawing a segment AB, an arc AB, so angles subtended by the same segment of the circle are equal. So basically they are saying that the angle subtended here by AB is same. So all these angles are basically y. So that is theorem 2. So angles in the same segment of a circle are equal. Okay, so that is our theorem 2. So basically theorem 1, theorem 2 is very similar and comes from the same concept. So basically one says that the angle subtended by an arc of a circle at its center is twice the angle subtended on any remaining part of the circle, and theorem 2 says that angles subtended by the same segment of the circle are basically equal. So subtended by this arc at any point on the circle are basically equal. Okay, so that is theorem 2. So let's move on to theorem 3. So theorem 3 also comes from a very similar concept and the same principle basically. So let us first discuss that. Okay, so let's say we have a circle up here and our theorem 3, so let me write it down. So theorem 3, what does it say? It says that if a line segment joining 2 points, so if a line segment joining 2 points subtend equal angle at two other points, subtend equal angle at two other points, what will happen? So if a line segment joining 2 points, so if a line segment, let us draw the line segment joining 2 points, subtend equal angle at two other points lying on the same side of the line containing the segment. So lying on the same side of the line containing the segment, then those 4 points are concyclic. Then those 4 points are concyclic. Now let me explain this to you, and let's not draw the circle first. So let us just draw the circle as we go on with the theorem. Okay, so let me explain in words and then we'll draw the circle later. So if a line segment joining 2 points, so we'll draw a line segment joining 2 points, let those 2 points be A and B. Okay, subtend equal angle at two other points lying on the same side of the line. So it is subtending equal angle at 2 points. So let's say point C and let's say point D. Okay, so these angles X and X, they are equal. So these line segment joining these 2 points subtend equal angle at two other points lying on the same side of the line. So either on this side of AB or the other side of AB, right? But on the same side. Then those 4 points are concyclic. Then they're saying that these 4 points lies in one circle. So they are concyclic. That is what the theorem says. And if you notice carefully, then this is basically the converse of what we had talked in the previous theorem, right? Because in the previous theorem we talked that any line segment will subtend equal angle at the circle, right? So if this segment or if this arc is subtending equal angle at the circle, then basically those 4 points are lying on the circle, right? So that is what theorem 3 says. So if this line segment is subtending equal angle at two other points, then all those 4 points are concyclic. Okay, so that is theorem 3. And there are proofs of all these theorems, which we are not getting into because since this is a revision, but you can always look at those proofs in your textbook. But basically, these theorems, what we are trying to do is explaining you the theorem and then we'll go on to the problems. Okay, so this is theorem 3, and again basically the converse of the previous theorem. Okay, so let's move on to our next theorem. So our next theorem is also an application of our previous theorem. So let's write it down and then I'll explain how it's an application. Okay, so the theorem the next theorem says that, so that is that's going to be theorem 4. So our theorem 4 says that the angle in a semicircle is a right angle triangle. So the angle in a semicircle is a right angle. So what does this mean? So it means that if we draw a circle and if we draw the diameter, then we get two semicircles, right? And the angle subtended on a semicircle is basically 90 degree. That's what this theorem says. Now, how is it an application of previous theorem? So let's say this, let's call it AB, and let's consider AB as an arc, or sorry, AB as a chord or AB as an arc, whatever you can call it, right? So how much angle AB subtends at the center? So if we see, this AB is subtending 180 degree at the center. So our first theorem says that the angle subtended by the center is double the angle subtended at any other part of the circle. So if the angle subtended at the center is 180, at any other part of the circle, the angle subtended would be 90. So theorem 4 is basically an application of the first theorem. Okay, clear? But this is a very important theorem and there are many questions that come from this theorem. So it's very important to know this. Okay, so we'll move on to our next theorem. So our next theorem is also basically the converse of this theorem. So let me write it down. So that's going to be our theorem 5. So what does theorem 5 says? It says that if an arc of a circle, so if an arc of a circle subtends a right angle at any point on the remaining part of the circle, so subtend a right angle at any part of the remaining or at any remaining part of the circle of the circle, then the arc is a semicircle. Then the arc is a semicircle. Okay, so basically what they're saying is if this arc is subtending an angle of 90-degree, then that arc is a semicircle. Okay, so is a semicircle. So basically they're saying that if any arc is subtending 90-degree, then that arc is a semicircle and the chord is basically the diameter. Okay, so basically just the converse of the previous theorem. Okay, and now let's move on to our next theorem. So let us go on to the next theorem. So our next theorem says that the opposite angles of a cyclic quadrilateral are supplementary. So what does that mean? So let's draw a cyclic quadrilateral. So cyclic quadrilateral means a quadrilateral inside the circle. Okay, that's a cyclic quadrilateral. So let's draw a cyclic quadrilateral. So any quadrilateral inside the circle is going to be a cyclic quadrilateral. So let's draw this. A, B, C, D is a cyclic quadrilateral. So opposite angle of a cyclic quadrilateral, let's say B and D are opposite angles. So they are saying that angle B plus angle D is equal to 180-degree, which is supplementary. Or angle C plus angle A or angle C plus angle A is equal to 180-degree. That's what this theorem says. So let me write that down in words. So this is going to be theorem 6. So what does it say? The opposite angles of a cyclic quadrilateral are supplementary. Okay, so that's the theorem. So the opposite angles will sum up to 180. The opposite angles will sum up to 180, and as you all know, in any quadrilateral, all four would sum up to 360, right? So that's a property of a cyclic quadrilateral. Cyclic quadrilateral, any quadrilateral inside a circle is a cyclic quadrilateral. Okay, and the next theorem is basically the converse of this theorem. So what does it say? If a pair of opposite angles of a quadrilateral are supplementary, then the quadrilateral is cyclic. So basically just the reverse of this theorem. So let's write it down. Theorem 7. And what does theorem 7 say? Theorem 7 say that if a pair of opposite angles, right, of a quadrilateral, so pair of opposite angles of a quadrilateral are supplementary, meaning if they add to 180-degree. Supplementary, then what will happen? Then that quadrilateral is cyclic. Okay, so then that quadrilateral is cyclic. So that is just the reverse of theorem 6. Okay, so that's our theorem 7, and let's move on to our last theorem, right? A lot of theorems, but kind of similar and very, very important, right? So it's just we have to know, and if you get time, take a look at the proofs. They are super simple, but the applications are more important than the proof. So we're going to go with the applications for now. So without further ado, let's go with the last theorem. That's going to be our theorem 8 for the session. So the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Okay, so let's draw it and try to explain what that says, and then we'll write it down in words. So the exterior angle of a cyclic quadrilateral. First, let's draw the cyclic quadrilateral. Okay, so we have the circle. Any quadrilateral inside the circle is going to be our cyclic quadrilateral. Let's name it A, B, C, and D. Okay, so an exterior angle. So let's extend something. So the exterior angle is going to be this. So let's call it E. So angle is DCE. That's the exterior angle, right? Is equal to the interior opposite angle. So what is the interior opposite angle here? So the interior angle and opposite of that, right? So that is equal to angle DAB. So angle DCE is equal to angle DAB. That's what the theorem says. Should be equal. So this angle and this angle should be equal. So let me write that down in words. The exterior angle. So the exterior angle of a cyclic quadrilateral is equal to to the interior opposite angle. Okay, and we explained it, right? So exterior angle equal to the interior opposite angle. So these 8 theorems are super important. Let's just glance over them one more time before we move on to our questions. So the first theorem says that the angle subtended by an arc of a circle at its center, which is basically this angle, is equal to is the double of the angle subtended on the remaining part of the circle. Meaning, if the angle subtended on the remaining part is y, the angle subtended on the center would be 2 times of y, right? So what is theorem 2? The angles on the same segment of a circle. So basically, if we have a segment of a circle, or if we have an arc, then the angle subtended by that arc or the segment of the circle on any point on the circle would be equal. So all these angles would be equal to y, right? So next one we talked about, if a line segment joining 2 points subtend equal angle. So this line segment AB and subtend equal angle on the same side. So if there's a point D and point C, and if this AB subtend equal angle on C and point D, then all those 4 points are concyclic. So that's theorem 3. So what was theorem 4? The angles in a semicircle is a right angle triangle. So if you have a semicircle, all the angles inside it would be a right angle triangle. And we talked that it's basically the application of theorem 1, because angle subtended by the diameter at the center is 180. So at the other points on the circle, it will subtend half of that, right? So basically 90 degrees. First theorem 4, and then theorem 5, basically the reverse of it. So if an arc of a circle subtend right angle at the remaining part of the circle, so if this arc subtend right angle at the remaining part of the circle, then the arc is the semicircle. So the opposite of theorem 4. Then we went to theorem 6, which is basically the opposite angle of a cyclic quadrilateral are supplementary. Basically, if we add these two, we'll get 180. So angle B plus angle D is 180, or angle C plus angle A is 180, right? So that was theorem 6. And theorem 7, again using theorem 6, if a pair of opposite angles of a quadrilateral are supplementary. So if we have in a quadrilateral, if we have angle B and angle D equal to 180, or C plus A equal to 180, then we can say that that quadrilateral is cyclic, right? And then theorem 8 is talking about the exterior angle. So here the exterior angle is DCE is equal to the interior opposite angles. So those are the theorems. So now let's move on to our first question. Okay, so let's start the practice with a question that came in our previous ICSE question. So it says that in the adjoining figure, O is the center of the circle. So this is O, and angle PBA, which is basically this angle, is 45 degree. So we have to calculate the value of PQB, which is what I have highlighted here. Okay, so how can we do that? So first of all, we see that AB is the diameter, right? Because O is the center, so AB is the diameter. If AB is the diameter, then what is angle PAPB? So the angle is 90 degree, right? So from one of our theorems, we learned that if we have a semicircle, then it subtends an angle of 90 degree at the center, at any point on the circle, right? So this angle is 90 degree. So if that angle is 90 degree, so let's consider triangle APB. So in that triangle, we have angle B that's equals to 45 degree, and angle P that's equals to 90 degree, right? So what is angle A? So angle A would be 180 minus 90 minus 45, right? So this angle is going to be 45 degree. So A is basically PAB, right? So angle PAB, that's basically A, what I've written as A, is 45 degree. So this is 45 degree. So now let's look at the chord PB or the arc PB, right? So arc PB, so let me draw it in different color. So this subtend an angle of 45 at A. So the same arc will also subtend the same angle at any other point on the circle. So you can see that PP also subtend an angle at Q. So those angles must be equal. So this PBQ must also be 45 degree, right? So angle PQB equals 45 degree. And the reason is subtended by the same arc, right? So see, very simple, very interesting question. But if you know the theorems, you can get the answer for this question. So our next question also will put up another previous ICC question, but give that question a try before we get into the explanation. So let me put that up. Okay, so this question is from ICSE 2013. So let's read the question. So in this figure, this angle BAD is given as 70. Sorry, it's given as BAD is 65, which is this angle. ABD is 70, which is this angle. And BDC is 45. BDC is 45, which is this angle. So first is proof AC is the diameter. So how can we prove AC is the diameter? So if we can find angle ACD, so if we can find a DC equals 90, or if we can find a BC equals 90. Either of that, if we can find and prove that they are equal to 90, then we can prove that um, AC is the diameter, right? So let's see, we are given in triangle ABD, basically we are given two angles, right? In triangle ABD, we are given angle ABD is equal to 70, and we are given BAD is equal to 65. So how much is angle ADB? That is equal to 180 minus 70 minus 65. So minus 70 minus 65 is 135 minus 180. That's going to be 45 degrees. So ADB is 45. So basically this is 45. So how much is angle ADC? That's equal to 90 degree. So if a arc subtend an angle of 90 degree, then that is a semicircle, right? Then that arc is a semicircle. So therefore AC is the diameter, right? So this AC, because AC subtend an angle of 90 degree on the remaining part of the circle. So the first proof is done, right? So what's the next proof? Find angle ACB. So ACB, we have to find this angle. So AB subtends 45 degree at D. So it will subtend 45 degree at any other point. So if it subtends 45 degree, let me use the yellow ink. So AB subtending 45 degree at D. So it will subtend 45 degree at any other point. So at C also it should subtend 45 degree. So this angle is 45, right? So AB subtend 45 degree at at D. So it will subtend the same at C. Therefore, angle ACB is equal to 45 degree. Okay, so very simple, right? If we know the theorems, then these questions are basically very simple. So I would like to conclude the session for this here. In our next session, we'll be solving a few more questions, and we'll discuss few more theorems, and we'll discuss more problems in our next session. And that would be the last session on circles. But hopefully, guys like the video and gain something out of it, especially the different theorems and kind of what especially those theorems are, and few applications on some real ICSE questions. If you like the video, give it a thumbs up, and if you like our content, to subscribe to our channel for more such contents. And all the best for your preparations for any board exam. Especially this is ICSE specific, but it's going to be applicable for any other board exams. So all the best, and I will see you guys in our last part of the circles video. Thank you, and bye bye.